Vanakkam, Namaste, Namaskar. Welcome back to Jal Prayag. Today, let us continue on the day's work question because the last video I made was the brief concept of day's work. So today I'm going to take a question. Let us try to solve a question. This question is going to be slightly with many steps because my idea is to make it quite simple and easy for people who are beginners, basically your BSc first year and DNS guys. So what I've done is I've tried to make it as simple as possible so that all the students, doesn't matter what is the caliber of each one of the students, all of them are able to understand the sequence of the steps, why, how we are doing and why we are doing day's work. So I'm going to split them into three videos. This one basic problem itself, that is why I marked as 1 alpha. I'm going to split them into three videos of just this one problem. So I'm going to do step by step. So I'll be doing only part in this 1A, then I'll do the second part in 1B, and then the third part in 1C, and then I'll be finishing off the question. So that way, anyone who is having difficulty in understanding the process, some people do have, those people also can understand each step. And so I have not tried to skip anything. I've tried to give it as maximum as possible. That is the reason for me to break them into parts. I'm going to start with a basic table because in day's work question, many conditions can be imposed and different types of data are given, which we'll deal later. I'm going to give you a straightforward question. That is one of the most simplest one. So let us say there was a vessel on 4th of November, and at 12 o'clock noon on this day, the vessel started sailing, or it could be sailing and is continuing the sail also, because day means noon to noon, we already seen. So at noon, it was sailing 236 degrees true, and it went on for a distance of 75 nautical miles. Then at 1700, she altered course to 284 degrees true, and this course went on for 48 miles. Then at 2000, the new course was 262, went on for 120 miles. It went past midnight, and at 4 o'clock again, which is the next day, which is 5th of November, she alters to 198 degrees true and 116 nautical miles. And this goes on up to noon. So basically, we have started from noon and ended up to noon. My first video is going to talk about only calculating of course made good and distance made good. That is what is called CMG and DMG from noon to noon. Okay. In the second part, I will not even go to the calculation of CMG, DMG in this. I'll try to do it in the second part of the video. So initially what I'm going to show is how you start a question, how you make a table. So that is what we are going to do. I'm not even going to calculate CMG, DMG. Okay. So I'll do it in the next video. So you can see this video itself might take a little bit more than 10 minutes. I want to stop my video somewhere around 10 minutes because there is something good for keeping you with attention on the video. So just maybe 10 to 12 minutes. Okay. So this last sentence, what I've written, I'll be doing in the next video, not on this one. Let us look at the basics. All I did was I took data from the question and I made a table. This table I'm going to keep extending. Okay. So right now I've given you just only 3 columns. Let us look at these 3 columns. You can see I've written legs, leg number 1, 2, 3, 4. These are the legs of the course. I have started with 12 o'clock, 4th November, and he said that the vessel sailed 236 for 75 nautical miles. Then at 1700, altered to 284, 48 miles. 2000, altered to 262, 120 miles. And 4 o'clock in the morning next day, 198, and sailed for 116 nautical miles. And this went on till 12 o'clock, which is noon of 5th. So that is what is the problem. Okay, I'm going to modify, I'm going to increase the columns slowly one by one so that you can understand the basic of this. Once you are familiar with this, you need not go by this. You can just make one complete table in one shot. Okay. This is for the beginners just to understand how we go step by step. Now, please look at this next slide. You can see there's a small change. You can see I had written 5 legs because I included a 5th leg as 12 o'clock on the 5th. But you should remember, we are finishing our noon at 12 o'clock on the 5th. So that means effectively there are only 4 legs. So that is why you can see I've just made 4 legs. Please look at the change in the first column itself, the time column. I've written 12 o'clock to 1700, I did 236. Then 1700 to 2000, I did 284. 2000 to 4 o'clock next morning, it was 262. And 4 o'clock till noon was 198. Now the whole thing is much more clearer than what was given to you in the question. There's something additional I have done. I have calculated a column called quad course, which is your quadrantal course. This is what I need for my day's work. So we have already done how to do quad course. So I'm not going to repeat that. You can go back to the other videos where I've done quad course. Now 360 notation of true course, I'm converting into quadrantal. Very clearly I've written south 56 west, north 76 west, south 82 west, and south 18 degrees west. So in quadrantal course, angles cannot be more than 90. The distance are same, which was there in the previous page. Now, I don't need the 3-digit course, which is your 360 notation course anymore. So right now, all I need is only the quadrantal course and the distance to solve my problem. Okay. Based on this data, let us see what exactly the ship did on this day. I'm going to show you in picture what exactly. So I'm going to show exactly what is here there. Okay. So let us say I started here at noon, that is alpha. The first course I did was kind of southwesterly. At 1700, I altered my course to northwesterly. At 2000, I altered my course slightly southwesterly again. And at 4 o'clock, I went on a new southwesterly course to reach my destination, which is the next noon. So this is what I have done in a day. This is what I have done in a day. Okay. Now, when you have this picture, which I already told you in the previous modules of day's work and the basics and all, each leg of this course, like from 12 to 17, 17, each one of them, I'm going to convert into a right angle triangle. And when I convert them to a right angle triangle, the 3 sides, one is the distance, another one is the D'lat and departure. These are the 3 sides of the triangle. And of course, there is an angle called the quadrantal course. So I'm going to show you how to split them. Okay. I'm going to show you how to split them. The same thing, exactly the same thing. Please see on the first leg, I've traveled southerly, that means D'lat is south. I've traveled westerly, so that means departure is west. Second leg, I've traveled northerly, so D'lat is north, and westerly departure. Southerly D'lat, westerly departure. Southerly D'lat, westerly departure. This is what I have done in a day, and I've broken them into pieces. Now, what I have done is, since I've added 2 more data here, that means D'lat and departure, I'm going to increase my column on my table. Now, let us see this table. If you can see, it is exactly the same table. I've increased the columns. What I've done is I added 4 columns in the last. You should realize the first 2 columns, which is blue and red, is D'lat. The second 2 columns are departure. Now, why I need 4? D'lat can be northerly or southerly, that is why 2. And departure can be easterly or westerly, that is why 2. Now, people make mistake while calculating and putting in this table. They do mistakes. They put in the wrong place. That means the wrong block. So that is why a small suggestion for you, before you start question, please put a big cross mark wherever the data is not needed. That way you will not do a mistake. Okay. Let us take an example of south 56 west. You have traveled southerly and you have traveled westerly. That means I need only southerly D'lat and westerly departure. I don't need D'lat north and departure east. That is why I put a big mark as cross. Similarly, for the second leg, the cross is the place I don't need any data. And the same thing for third and the fourth also. So this is what you should be careful in making the table. Okay. So once you make this table, you are ready for the next step actually. The next step is putting in those data. So how do you put these data which I marked with question mark? That can be done by solution of plane sailing triangle, or which is called the plane sailing. We have already seen simple cases of plane sailing. Okay, I'm going to take, let us take the first leg. The first leg was 236 degrees and distance 75 nautical miles. If you convert that into quadrantal course, which we have already done, it is south 56 degrees west. So I'm going to draw that basic triangle. You see this basic triangle, A to B southwesterly, which is 75 nautical miles. This is the distance. This is the course given to me as 56 degrees. And I'm traveling southerly D'lat and westerly departure. Okay, this is your basic triangle. Now, how can I solve? If you remember, we had the three formulas for this triangle: cos, sine, and tan, using the three sides as an angle. So I'm going to choose cos. Why? Because I have some data here. You can see I have theta as 56 and I have distance as 75. So I can calculate D'lat. D'lat is 41.9 minutes. This is the D'lat. Okay, I already got a D'lat now. Now, since I have two sides, which is 75 as distance and D'lat as 41.9, I can use your Pythagoras theorem. And you will see when I put it, I get an answer called 62.2 miles. So I've got the third side also now. I have all the three sides and the angle. In other words, I can use even sine theta also. I could have used tan theta also. You'll have a very minor difference of the decimal values. Don't bother about it. Each method has got its own differences, and your calculator also. And all nautical miles or minutes readings, please round off to only one decimal. That is why I've written one decimal. So what you have done is you have calculated the two data, the D'lat and departure for the first leg by our traditional calculator method. Now, I'm going to take example. This was leg 1. I'm going to take example of leg 4. The leg 4 was 198 degrees and 116. I could have done this exactly the same way. South 18 degrees west. So I could have drawn this diagram. I could have used any of these formulas. I could have still done it. But I'm going to slightly deviate. I'm going to show you something called traverse table. Okay. The traverse table is a booklet, which is also called as Norris table. It's a part of that Norris table. It's a very useful tool. Nowadays, it is not being used. It's not being distributed in the colleges also, but it's a very basic one. So I thought I'll just give you a small gist about it, how to utilize in this particular question. Okay, I'm not giving you any more detail. The picture is slightly faded. Please bear with me. All I want to show is how to use it. I'm going to show you a traverse table. Okay, this is a traverse table. Traverse table, if you remember here, we had a course of south 18 degree west. So that is why I've chosen the page which has got 18. If you see on the left hand top, 18 degrees. This table is nothing but a quick guide. If someone gives you a quadrantal course which is 18 degrees and gives you a distance, see, you can see in that column on the top, you have a distance and then it's a D'lat and departure. The distance is highlighted in bold. I'm going to choose this 116, which is for this leg. So I'm going to go down. I have highlighted one. As I said, the picture is slightly blurred. Bear with me. That 116 distance and 18 degrees directly can give me D'lat and D'long departure. I'm sorry. And that is what is this. This is the value which is there in the block. So I've already calculated D'lat and departure by just looking at a traverse table. So this is the beauty of traverse table. But anyway, it's a very old system, a foolproof system it was. There was very less chance of doing errors because everything was calculated and given to you. But nowadays it is not available, but still it's a basic you need to understand. Maybe old still seafarers, when I say old, maybe 6, 7 years old, they still will have this book, and they can take it for exams also if it is allowed inside your examination hall. Okay. So what I have done is I've shown you example of leg 1 and leg 4 with two different methods. Rest of the legs you can calculate. So I'm going to give you the answer directly. These are the answers for the different legs. What for two legs I showed you, number 1 and number 4, but these are the values. Okay. This particular module I'm going to stop here. Why? Because it is going to become very lengthy. So all I have done is for each individual leg, I've calculated the D'lat and departure. Okay. So let us stop here. We can actually, I can still go on telling about this resultant also, but what I will do is I will talk about this in the next module. How to continue on this. Basically, all I'm doing is doing an algebraic sum, and finally I'm finding the resultant. So what I will do is I'll stop it here. The basic step was to help you how to make the table and find out D'lat and departure for each. Like that is what we have done. I'll continue from the resultant part of it in the next module. Okay, next video, and it'll become easier for you, and that is why I've written continued in the next part. So let me not overload you here. It should be enough for today. So I hope the initial part was good enough, and I guess it is good enough. It should be helpful for you. I'll come back to the next two videos soon. So please keep watching Jal Prayag. Till then, Vanakkam, Namaste, Namaskar.